Testing, testing, 1, 2, 3. Oh. Hello, everybody. Welcome back to another video of... Alright, so you may have noticed I missed a couple Tuesdays in there. My bad. I was doing stuff. Anyway, I have a lot of topics that I want to talk about on this channel. Like, I have a whole list of stuff, but the first one, highest priority, is I need to talk about these 3 monsters. I don't know why everyone's obsessed with these monsters. Like, everyone wants to know the answer. So, first of all, if you don't have the book, well, you should get it. It's only $18. There's a bajillion editions of it now, paperback, languages, etc. But throughout the book, I have these little, like, interstitial things, you know, with, like, bonus games and, you know, just, like, cool stuff about the moon and the sun, stuff about theorems, things that are impossible. And one of them is I put this logic puzzle about 3 monsters guarding 3 doors. One thing that I did is I did not put any answers to any of the puzzles at the back of the book. You know, in math, sometimes you come up with a problem and you don't know the answer to it. And the answer is not always like at the back of the book. Sometimes you need to like puzzle over it for a while. That was the intention. It seems like maybe some people were frustrated by that because sometimes you do just like want to know the answer to a riddle, including when I was like working with translators and publishers. They were like, okay, we love the book, but what is going on with these 3 monsters? How do we solve this problem with the 3 monsters? So I'm making a video. Here we are. We're going to tell you about the 3 monsters. So we're starting with a pretty classic logic riddle setup. We're trapped in a room. Don't know how we got there, but that's where we are. We're trying to get out. There's a couple doors. One of them is leading to doom and despair, you know, endless torture. You don't want to go there. And the other 2 are exits. You can go back home, so that's good. But unfortunately, these doors are, of course, guarded by 3 weird logic monsters. And these monsters have very specific rules about whether they tell the truth, lie, etc. And in particular, in this case, we have 3 identical triplet monsters. They're identical, but the youngest always lies. The oldest always tells the truth. And the middle is the trickster. So the trickster is the weird one. The trickster can answer however they want. And this is what makes this puzzle different than some other logic puzzles, because usually you've got the liar, you've got the truth teller. This one, the trickster is really what's confusing here. The trickster messes everything up because, you know, you really just like, no matter what you ask the trickster, she can tell you anything and you like won't get any information out of her, basically. We're trying to get out. You get to ask 1 question to 1 monster 1 time. And then you have to choose a door. We do know actually that the trickster monster is guarding the doom door. You don't want to go there. And the other 2 doors are both safe. The problem is that, of course, they're not arranged in age order and they're all identical. We have no idea who's who. We have no idea which one's which. So we want to have a 100% chance of getting out the correct door. You know, you could already from the outset, 2 out of 3 doors are good, but we don't want to take any chances with eternal pain and torture. So we're trying to find a strategy that makes it so that we 100% chance get to a door that is safe. So the question is, what do we ask? And then how do you choose? So this is the part where I'm going to put up the thinking card. So if you want to take a minute to pause and think about this and try to figure it out for yourself, now's the chance to do it. All right, but let's be honest, you're on YouTube because you don't really want to think, you just want to have people tell you things. So I will walk you through the answer. The way we're going to get there, though, is first I'm going to solve a simpler problem. This is like always a good thing to do if you're stuck. I mean, it's true in math. It's true like in most areas of life. If you're having trouble with something, just do like a simpler version of it. See if you can work your way through an easier version of the same problem, and that'll help give you strategies and techniques for doing the more advanced part of it. So instead of doing the 3 monsters logic problem, a lot of people might be familiar with the classic 2 monsters one. So this is the one where you have 2 doors. And you just have 2 monsters. And these 2 monsters, you've got 1 liar, 1 truth teller. Again, they're identical. You can't tell which is which. In this version of the problem, we don't know, for example, that the liar is guarding the good or bad door. All we know is that there's 1 good and 1 bad, and there's 1 liar and 1 truth teller, and we're trying to figure out what to ask. Now, the 1 question limit is a really significant problem here because you could just ask, you know, a very straightforward question like, is the sky blue or is 2 + 2 4? Sorry, I'm not supposed to say numbers. And then you just get the answer, and you know from that answer whether you're talking to the liar or the truth teller, and then your follow-up question is, okay, which door is the safe door? But we're not allowed to do that because you only get one question. That's just the rules. So we're trying to figure out a way that we can use our one question to get an answer about the door, and it shouldn't depend on whether we're talking to the liar or the truth teller. That's the tricky part. And the reason this is such a hard classic riddle is because usually if you ask a truth teller something and you ask a liar something, they're going to tell you opposite information. And we need to get an answer. We need to get a straightforward answer that doesn't depend on who we're talking to. So what we need to do basically is find a way to get the same answer from the liar and the truth teller. And the way that you do that, I'll just tell you the answer to this one, is that you kind of cross-reference them. So the truth teller tells factual information, the liar tells lies, but if you get them to talk about each other, you can sort of get it to, in like a almost double negative way, cancel out. So, you know, one question is, for example, does your twin tell the truth? Think about what that would mean. If you ask this to the truth teller is going to say, no, my twin does not tell the truth. My twin is a liar. So they're going to say no. If you ask the liar this question, they're going to know, well, yeah, my twin does tell the truth, but they're going to lie and they're going to say no. So this is a way that you can get the same answer from a liar and a truth teller by sort of cross-referencing them. Unfortunately, this doesn't tell us anything about what's the correct door, so we have to find a way to cross-reference and ask about the doors at the same time. And so the solution to this original two monsters riddle is, what would your twin tell me is the safe door? So if you ask this question, what would your twin say is the safe door? Let's see what each of them would say. If you're asking the truth teller, they're going to say, okay, my twin, the liar, is going to point you to the doom door. So the truth teller is going to point to the doom door, say that's the one. Now, if you're talking to the liar is going to think, oh, I know the truth teller is going to tell them the real door, the safe door. So I'm going to lie and I'm going to point to the doom door. So we found a way to get both of the twins to point to the same doom door. So the strategy is you say, what would your twin say is the safe door? And then you pick the opposite of whichever one they point to. Ta-da! All right, now let's get to the real puzzle here. There is a sort of logical chain of ideas that gets you to the answer. And so I'm going to walk us through those ideas. The first idea, which I'll call idea A, is that talking to the trickster gets you absolutely no information. No matter what you ask and no matter what answer you get, talking to the trickster is completely useless. The trickster's answer is just completely vacuous of information. They can say yes, they can say no, they can just flip it around. It really doesn't matter what the trickster says. So you need to go in knowing that. And that's significant because, of course, we don't get to decide who we're talking to. So if we are so unlucky as to have chosen the trickster to be our person that we're asking the question to, we're going to get absolutely no information out of the question. That's enough for some people to look at this and say, okay, so this riddle is impossible. How can you possibly answer it if you don't get any information from the trickster? And that's why it's a really crucial part of this riddle that the trickster is the one guarding the doom door. Because we don't actually need to figure out what all the doors are, what all the monsters are. All we need to do is identify one door that's safe. So really what we're doing is we're coming up with a process. We're coming up with a process where we ask a question and then based on the answer to that question, we choose a door, right? And we want this to be a consistent process that always leads us to a safe door. So this leads us to our second, or B, observation, which is our process cannot involve any situation where we choose the door behind the monster we are currently talking to. Think about that. If we have a process where it's like, okay, I ask you this question, whatever the question is, and on yes, I will take the door behind you, and on no, I'll do some other thing, then we're leaving ourselves open to a world where the trickster says yes, and we choose the doom door. We can't do that. So under no circumstances, under no answer choices, can we choose the door behind the monster we are asking the question to. And that's really the key piece of information here, is that whatever we're doing, we're asking a question, and based on the answer, we're choosing one of the other two doors. So that leads us to our final observation, observation C, which is we need to pick a question that is going to have the youngest, aka liar monster, point us to the oldest, aka truth teller door, and is going to have the oldest, aka truth teller monster, point us towards the youngest, aka liar door. Let's think about this. What can we ask that will make the youngest monster point to the oldest monster and will make the oldest monster point to the youngest monster? I'll put up the thinking card again here because now we've worked through most of the hard parts of the problem. Maybe this is, you can do the layup at this point. All right, you didn't pause the video, right? You just want to know the answer. So a question that you can ask, and there's multiple solutions, but one question that you can ask is, which of your siblings is younger? So let's think about why this works. If you're talking to the youngest, aka the liar, then they're going to say, okay, between my two other siblings, well, the middle trickster is younger, so I'm going to lie, and I'm going to say that the truth teller older sibling is younger. If you're talking to the truth teller is going to say, well, my youngest sibling is younger. My liar sibling is the younger one. And if you talk to the middle trickster sibling, it doesn't really matter which way they point you because either of those doors is safe. So that's the solution. Which of your siblings is younger? Which of the other monsters is younger? And then you go to whatever door they point you to. This is why the sort of youngest oldest thing is nice and useful in this question. There's also ways to solve it. I've heard people come up with solutions that don't involve the younger older thing. You could say something like which of the other two triplets is more likely to lie, and that's exactly the same as this. But this one's nice because it lends to like a very simple, straightforward answer. And in fact, you could shorten this to 3 words if you say like which sibling's younger. So that's kind of nice and elegant. And now the last question that I get about this riddle is, did you make up this riddle? No, I did not make up this riddle. This is a well-known riddle. I found this on the internet. I think I found this on like an XKCD forum like 10, 15 years ago. And all I did is I changed like the superficial characteristics of the problem because I didn't want it to be Googleable. But the original problem is, I think it's called like the 3 princes or 3 princesses riddle. You're a knight, you slayed a dragon, the king offers you one of his daughter's hands in marriage, the youngest always lies, oldest always tells the truth, middle is a trickster and does whatever she wants. It's a weird king, you only get one question one time. You want to marry either the youngest or oldest because you just want to always know where you stand. At least if it's a liar, you can always like reverse it and get the correct answer. So anyway, this is a riddle that already existed, and all I did was I changed it to be monsters and doors. There's a word for this in math, and this is kind of a rough application of the math concept of isomorphism. So isomorphic literally means same shape. In math, it's like when 2 situations are exactly identical in terms of their abstract structure, but then on the surface level, there's like a different appearance of it. So this is isomorphic to the 3 princes riddle. That's it for today. So if you have any other questions about things that were in the book that you wanted an answer to and didn't get an answer to, make sure to put those in the comments. There's a lot of stuff that I will eventually cover. But next week, I think I'm going to actually talk about a different problem that I don't believe I put anywhere in the book, which is the cross and a block problem. This is one of my all-time favorites, so be sure to tune in next Tuesday. And if you haven't already, please subscribe to the channel and purchase the book. Ta-da!